This is the third and final video for volume, section 7.3 in AP Calculus. So far, we've looked at volumes by taking cross sections, volumes through discs and washers by rotating around the X or the Y axis. And so today, we're going to do volumes by rotating around an axis again, except this time, rather than it being specifically the X axis or the Y axis, we're going to rotate around some horizontal or vertical line. So we're just going to jump straight in to some examples. Now this is very, very similar to the discs and washer method that we've been using with the x-axis and the y-axis. The only thing that's changing is that that axis is shifting vertically or horizontally depending on which axis it's parallel to, x or y. So here, for example, we want to find the volume of the solid that's formed by revolving the region bounded by f of x equals 2 minus x squared and g of x equals 1 about the line y equals 1. So we've got some really great visuals going on here. You can see the region for 2 minus x squared and y equals 1. It's the blue parabola here in the first graph, and we're going to rotate it around the line y equals 1. In rotating it, we end up with the shape that you see in the second figure here. Not quite a sphere because it's a little pointed at the ends, but that type of shape. Regardless though, because it's formed by rotating our graph 360 degrees, if I was to slice that solid perpendicular to the axis of rotation, then I'm going to end up with a circular cross section. So you're still just integrating pi r squared. The only difference is how we find the length of the radius. So the area formula for a circle is pi r squared. The radius, however, is calculated a little bit differently. Because the axis of rotation is not the x-axis or the y-axis, it's y equals 1, that's parallel to the x-axis. So we're still going to approach it the same way that we approached x-axis rotations. If we're rotating around the x, then we integrate with respect to x. So since we're rotating around a line that's parallel to the x-axis, we are going to rotate, or we're going to integrate with respect to the variable x. Okay, so I do know that for my volume formula, it's going to be pi times some sort of radius squared with respect to x. Now, the length of that radius, they've kind of drawn it in here for us. We have to almost think of this like a translation from the x-axis to whatever our new axis of rotation is. So if you think about shifting things up or down, all we do to shift things up or down is we add or subtract a number to them. So in this case, to find the length of this full radius that we have here, you're going to take the axis of rotation minus the function, and that's going to give you the length of your radius. So in this case, my axis of rotation is y equals 1 minus the function 2 minus x squared. And so that ends up giving you your function like that. Now, would it have mattered if I had reversed the order since the function is farther away from the x-axis than the axis of rotation is? Well, if I had done it in the other order, let's see what I would get. I would have 2 minus x squared minus 1. That function is going to end up being 1 minus x squared. This function, when I distribute, is going to end up being negative 1 plus x squared, or x squared minus 1. Now, let's kind of look at what the volume would look like doing it both of those ways. If I do it with the r sub 1, then that would be x squared minus 1 squared. Okay? And then when I FOIL that out, I know I haven't put boundaries yet, but that's okay. If I FOIL that out, that ends up being x to the 4th minus 2x squared plus 1 that I'm integrating. Okay? With this other guy, this volume formula, if I do 1 minus x squared squared. That ends up being 1 minus 2x squared plus x to the 4th. Notice it's the exact same function. It's written in a different order, but it's the exact same function. So what I'm trying to show to you here is that it doesn't matter the order that you find the length of your radius in. As long as it's the axis of rotation minus the function, or the function minus the axis of rotation, the order you subtract in doesn't matter because of the fact that we're squaring it when we put it into our pi r squared area formula. So going back to my volume formula now, I've got pi times the integral of x to the 4th minus 2x squared plus 1. I do need some boundaries. Since I'm integrating with respect to x, it would go from this x coordinate to this one, which looking at my graph, I can plainly see that that's from -1 to +1. Now at this point, you could integrate that by hand if you want to, but since most of these are liable to be calculator questions or simply find the integral to find the volume, I'm okay with you doing math 9 at this point, but I do want you to keep leaving that pi kind of out to the side. So if you integrate x to the 4th minus 2x squared plus 1, you end up with 16/15, but then times the pi. So you would get 16 pi over 15 as the volume of this solid. All right, so let's look at a second one now. So find the volume of the solid generated by revolving the region bounded by the graphs of y equals the square root of x, y equals 0, and x equals 3 about the line x equals 3. So I don't have a graph here, so the first thing I'm going to do is kind of make a rough sketch of what I'm working with. Y equals the square root of x looks like this. Y equals 0 is going to be the x-axis. And then x equals 3 is some vertical line here. So I can see that the region that I'm going to be rotating is this rounded section. And I'm rotating it around this line, this vertical line, x equals 3. So when it rotates around there, that's going to be what my cross section ends up looking like, is that kind of semicircular shape, which means I'm kind of creating a hemisphere here when I do my rotation. The other thing that I notice is that the line that I'm rotating around, that x equals 3, it's a vertical line, which means that it is parallel to the y-axis. So I'm going to be integrating, when I go to find my volume, I'm going to integrate with respect to y. And I already know that it's going to have a pi in front. I now just need to figure out how to find the length of my radius. So the length of my radius, if I go from the axis of rotation to the edge of my region, that represents the length of my radius. So if I do right minus left, then that would give me the length of my radius. The problem with right minus left is that this equation is not written in terms of y. It's written as y equals the square root of x. So I need to square both sides of it. So x equals y squared. So my radius is x equals 3 minus x equals y squared. So that gives me the radius of my function. I then also need boundaries. Well, I can tell, since I'm integrating with respect to y, I need the lowest y value, which I can easily tell is 0, to the highest y value, which occurs right here. That occurs at the intersection of x equals y squared and x equals 3. So that means that y squared would equal 3. So that point is y equals the square root of 3. Now your integration is all set up. Again, oh, one thing I didn't do is I forgot to square my radius. So that's r squared in there. Now you could work this out by hand if you want to, math 9 it, whatever. You're welcome to pause this and give it a try by hand yourself just to kind of test your integration skills. But your final answer should be 24 pi times the square root of 3 all over 5. That's what the exact answer is for 8.314 pi. Or if it had been multiplied through by pi, 26.119. And in terms of how you write the answer, it really doesn't matter. Exact is better, but if it's multiple choice, you just need to be able to recognize your answer choice however it's presented as your options there. Okay, so we've done one parallel to the x-axis, one parallel to the y-axis. So at this point, we're just kind of trying some other things out here. So we've got find the volume of the solid generated by revolving the region bounded by the graphs of the equations about the given line. So we've got y equals 2x squared, y equals 0, and x equals 2 about the line y equals 8. So, rough sketch. Y equals 2x squared. The parabola that starts at the origin down here. That's 0, 0. Y equals 0 is going to be the x-axis. X equals 2 is going to be a vertical line. So the region that I'm rotating is this region right here. I'm then rotating it around the line y equals 8. Y equals 8 is that line right there. So that line is parallel to the x-axis, so I already know that when I do my volume, I'm integrating with respect to x. Now I just need to figure out how to represent my radius in terms of x, and then what my boundaries are. So to find my radius, just like what we did with discs and washers, you start by putting a point on the axis of rotation, and then you draw to the farthest edge of your region. Now notice when you do that, you go actually through two boundaries of your region. That means that we have a little r and a big R. Finding those is no different from the last two problems where we've had two radii though. Little r, if we do top minus bottom, and big R, top minus bottom. Okay, so my little r is going to be 8 minus 2x squared, my big R is going to be 8. So that makes my volume formula big R squared minus little r squared. And then my boundaries, they're going to be in terms of x. My leftmost coordinate is 0, and my rightmost ends at x equals 2. So that's all set up like that. If you want to work it out by hand, the biggest thing to remember is that you have to FOIL out the 8 minus 2x squared first, and then do 64 minus that before you finish the integration by hand. When you do it, though, you would get 896 pi over 15 as your final exact answer. All right, so example 4 is very similar to example 3. So what I want you to do is I want you to pause the video at this point and see if you can work it from start to finish all the way through. All right, I got a lot of colors and a lot of stuff going on. So I sketched my graph. Notice the graph of 4x minus x squared is a parabola that opens down with its vertex is at this point of intersection right here between it and y equals x squared. I found that point of intersection on the bottom right there in green by setting my two equations equal to each other and solving for x. So that was the point 2, 4 is my point of intersection. Not that I needed the y coordinate, but there you go. So then when I drew in my segment from the axis of rotation to the farthest region of my part that I was rotating, I noticed that I had two radii again. Notice when you're setting this up, it's the big R squared minus the little r squared. You're squaring the r's individually. I cannot tell you how many people mess up and want to do big R minus little r and then they square it. Make sure you're squaring the radii individually. On FRQ questions, a lot of times there will be one point in the problem simply for having it set up with big R squared minus little r squared. Then there's usually a second point for having the pi and the boundaries correct. So pi from 0 to 2, that would have gotten you a second point. And then a third point for finding the actual volume. So this is 3 points of a 9-point FRQ wrapped up in these volume problems. And I can pretty much guarantee you you're going to have a volume problem on your AP exam. One part will be finding the area between the curves. Another part will be finding a volume, whether it's by cross sections, discs and washers rotated around the x or y axis, or maybe it's rotated around something like this, like the line y equals 6. So you need to be prepared for any kind of volume problem that could possibly be thrown at you, because I guarantee you, you will see volume.